So up to now we've been looking at mechanical systems that are subjected to loads along their long axis. So either a force trying to extend a system or a torque trying to twist the system. And what I'd like to look at now is what happens if I apply loads transverse to the long axis. So either a force vertically or a moment orthogonal to the axis. So if I bend it with a moment or I bend it with a force, I'd like to have a complete mechanical theory to describe that type of deformation. So it's a very common type of deformation. And to help us, what I've done is I've scored some lines here onto the surface of this beam. So there's a long horizontal line here and a bunch of vertical lines. And so what we'd like to do is make an observation of the motion of the system, make some kinematic assumptions, and develop a theory that allows us to describe it. And what we're really after is connecting motion to strains, because strains are connected to stresses, which are connected to the forces. So let me go ahead and bend the system. And if we look at the horizontal line, we see that it moves vertically, and so that's a primary part of the motion. But each of the vertical lines rotates. They do move up. They move up with the horizontal line, but they also rotate. And we also see that they all have different rotations. The angle between the horizontal line and the vertical lines, it remains 90 degrees, so that makes it a little bit more simple for us to look at what's happening too. So, and the other thing to notice is that the vertical lines, they remain straight. So we have a plane sections remain plane assumption for the cross sections, and each cross section moves vertically and it rotates. And what we'd like to do is take that and build it into a mathematical theory that describes the strains. And what we're looking for is something that gives us strains that are in compression in the top and in tension in the bottom.